Next time we are going to go into extraction, and this is going to be about the combination of any of those solvents, because recrystallization and recrystallization require a lot of organic solvent, right? So if we do not have an idea, and if we do not familiarize ourselves with the organic solvent and how it works, is it soluble, not soluble, when we're going to mix them together, we're not going to be able to use them in the recrystallization of organic compounds. Number one, which is really important, is what do we mean? Is the definition of solubility? No? Sorry? To dissolve. Right? Yeah, that's correct. But the thing is, there are restrictions about it. It's not like, you dissolve and that's it. It is exactly the amount of the solute. Now we know solution. If we want to dissolve a solid into a liquid or a liquid into a liquid, I'll give you an example. For instance, the table salt is a solid into a liquid, right? But how about the alcohol? Like the alcohol, the beverage. Both of them, both chemicals could be or substance could be two or more liquids, right? Getting together. So we need to understand how we are going to identify which one is going to be the solvent, which one is going to be the solute. In general, solution is made with two components. One is called the solute, whether it is liquid, solid, or gas, regardless of the state, okay? There is a solute component and there is a solvent component in the solution. Those two combine making the solution, okay? Which is one layer. Remember, there are mixture, hetero, and homogeneous. So when we have homogeneous, meaning we have solution. And solution made with two components, solute and solvent. So when we talk about this combination, the solute and the solvent, and the solute is going to possess the least percentage of those two. That's how we're going to identify it. So the solute is going to have the least percentage, and the solvent will have the highest percentage. So if we, let's say, have 20%, this has to be 80%, right? And if I have 1, the rest is going to be 99, okay? So percent-wise, solute is always going to be less than the solvent. And we know that, when you're going to dissolve the salt or the sugar in your cup of whatever, like tea, or if you have sugar, then definitely the sugar is less than the water or the mixture of the tea or the coffee. Otherwise, you're not going to be able to dissolve it, right? And this is what we're going to experience today, the amount of the solute and the amount of the solvent in this mixture. All right? Solubility is the amount of the solute, dissolved in a given amount of solvent at a specific temperature. Why do you think we have to mention the temperature? And we mentioned that maybe before or not? Why do we have to mention in a specific temperature? Solubility is different, right? With what? What is the other factor affecting solubility? Temperature. In other words, give yourself an example. If you wanted to dissolve the sugar in a hot water and in a cold water, which one is going to be dissolved first? Which one is going to be dissolved first, right? The hot, right? So that means when you change the temperature, solubility will be changed. And this is exactly what we are going to experience today. So I have to bring, the hot plate, and then maybe everybody will use one communal, and I'm going to put it in the back. But anyway, this is what we mean by solubility. Also, there is another factor which is affecting the solubility. And we learned that in general chemistry as well. I'm sure you learned or you heard this word, it says like dissolves like, right? What do we mean by like dissolves like?
It's like a polar and polar.
Exactly. And nonpolar will dissolve in nonpolar solvent. So again, this is the practice that we're going to implement today. As a polar compound, hopefully everybody knows what do we mean by polar, right? That has extra heteroatom with electronegativity higher than the others, right? Which is going to make it polar comparing to nonpolar. In other words, if I have hexane comparing to water, water is polar, hexane is nonpolar. Hexane is just 6 carbon atom with hydrogen and carbon. Does not have heteroatom, which is more electronegative. So this is non-polar and this is a polar. And we're going to find out which one is going to dissolve in those two. So like dissolves like. In other words, if we are going to have a polar solvent, that means all the polar compounds are going to dissolve in polar solvent. And one of the examples is water as a very good polar compound, solvent, right? Now, if we have nonpolar compound, and those are probably, we are going to have some of these that it is going to be nonpolar, and we are going to find out, for instance, hexane with methylene chloride, how is it going to react? Are they going to make 2 layers or 1 layer? So, in other words, hexane, because it is nonpolar, it is going to dissolve in with a nonpolar compound, okay? So this is how we are going to be able to compare, to know how we are going to probably prepare a combination of 2, or sometimes we need 2 or 3 solvent to be able to dissolve a solid or dissolve another chemicals, okay? Sometimes we need it mild. We don't need it too polar like water or too nonpolar like hexane. So we are going to go into methylene or ethyl acetate, which is in between the two. So something like that we need to learn about it because maybe the compound is not that much very, very polar. Like I gave you one of the example, benzoic acid, and then if you look at the vanillin, which everybody should know that, what's the structure, because actually we did have it before. So I'm going to draw it probably because it's not here. It's over here. And we should know it. And we have C double bond OH. So this is vanillin. And benzoic acid is that. And the this is biphenyl. So what do you think biphenyl? Is it polar or not polar? Biphenyl, is it polar or not polar?
Non-polar.
Non-polar. How about benzoic, which is, this is the structure. It's the ring. I don't know if you can see it because that's abstracting some of you. Double bond OH. This has 2 high oxygen and it is very, very polar, right? So when we compare those 3, and then this one is a mild in between the 2, vanillin. And how it is going to react with water, which is very, very polar. Then we have methanol, which is also polar. And we have hexane. And keep the 4th one as a control. Okay, don't add anything to it. So basically, this is how we are going to compare. For the first part, it says investigate solubility of the solid in a different solvent. So that's part 1. Okay, part A, we're going to have 4 test tubes. These are the test tubes that you are using, 4 of them. You have the test tube rack, you put them, 4 of them. Keep one, add those chemicals, right? And keep it as a control. The first tube, you're going to put these chemicals in it. And the first tube, you're going to have water. Everything is 1 ml. 1 ml of the water into the first. In other words, you are going to measure 40 milligram of each chemicals. In other words, for each chemicals, you're going to need 4 test tubes. Is that clear? Yeah, because we don't want to mix them, right? So for each chemicals, we are going to need 4 test tubes, right? The first, and then we're going to measure 40 milligram for, let's say, the first chemical, which is biphenyl. We add 1 ml of the water to the first. We add to the first tube. The second one, 1 milliliter of methanol. This is alcohol and it is polar. Then we have hexane. We have hexane. You should know what's the hexane. CH3, CH2 times 4, and then CH3. This is the structure of hexane. It's just chemistry. Carbon and hydrogen. It's hydrocarbon compound without any, and it is long chain. It's like 6 carbon atom, and does not have any like of the hetero atom with electronegativity. So anyway, we add that to the third, and the fourth one, as I mentioned, we're going to keep it controlled. We do the same thing for benzoic acid, and the same thing for vanillin. All right, and then check and see how it is going to react with those solvents. 40 milligram, meaning 0.04 of the gram. That's what it means here. 0.04 of the gram. And you have the very sensitive balance that you can weigh with it. I put the weighing bolts over there. You have the spatula. You are going to be able to, measure all the chemicals. The 3 chemicals are there, and use them as you go for part 1. As for part 2, or B, solubility of different alcohol within the same of those 2. One is water is polar, hexane is non-polar, right? So we're going to have those 3. So octane, how many carbon atoms? 8, right? So I have CH3, CH2 times 7, and then I have OH. That's octanol, right? And then butanol, how many carbon atoms? 4. So I have CH3, CH2 times 3, and then OH. And the last one is only 1 carbon atom. Okay? So, different length, right? And we know, although they do, 3 of them has the hydroxy group, which is more electronegative, right, than carbon and hydrogen, and we might expect them to be polar, but because we have a long chain, it is going to reduce or increase the solubility in polar. When we increase the number of carbon, is it going to increase the effect of hydroxy group or decrease as we increase the number of carbon? Decrease, right? So we can see between those 2, maybe when we have octanol, it could be non-soluble in water, and that's what you are going to observe today, okay? Yep, is that clear, everybody? All right. So this is part B, and then we have part C. It says miscible and miscible. Meaning, is it going to be soluble in water or non-soluble in water? This is a very good combination. It tells you. You're going to take it as a guideline for the following lab when we're going to do recrystallization or crystallization. So you're going to have a combination of water with methanol, which is ethyl alcohol, that is CH3CH2OH. It's not like, it's ethanol, not methanol. Methanol is that. Only 1 carbon atom. This is 2 carbon atom. And then water with diethyl ether. Diethyl ether, we all have to know that. Ethyl, CH2O, and then it is CH2CH3. This is diethyl, and that's the ether. Then we have methylene chloride, CH2Cl2, and we have the hexane, right? So this is all water with diethyl ether, water with methylene chloride, water with hexane, and water with methanol. Okay, sorry, ethanol. The last one, so we have 1, 2, 3, 4, 5. 5 test tubes, okay? The last one, you're gonna have hexane with methylene chloride. Each one of them, again, if you look at it, I believe each one of them will need 1 milliliter, and then you mix them together, okay? Is that clear? Do you have a question about these? All right, now the last one, we are supposed to pick one chemical which is acidic and the other one which is basic. Now, the other one is amino acid. I don't know if you used that before, but the structure of that is going to be like that. I have NH, excuse me, NH2, and then I have the C, and then we have, like, you know, a carbonyl on one side. You know that, like, you know. And then on this side, I have CH2 times 4, and then we have NH3 plus. It is like a salt, sorry. And it is a powder, by the way. So this is considered, remember arginine, lysine, and histidine, those are the basic amino acid, and aspartic, right? The others are the acidic amino acid, and we have neutral amino acids, right? So those are the essential amino acid. Hopefully this will act as a base. So this part, which is D, is going to implement or, like, you know, practice the solubility of organic acids and base in an inorganic acids and base. Okay? So we are going to have 30 milligram of each of the solid in the test tube. And then we are going to have 3 test tubes. We have water, and we have the third one, you're going to put 1 ml of the 1 molarity sodium hydroxide, and this one also 1 ml of hydrochloric acid to the same chemical, benzoic acid, okay? And then we are going to be able to find out, like, you're going to see a circle horizontal between the two, right? And then you're going to find out if it is going to make, apparently it is going to be 1 layer or it is going to be 2 layers. After you add this, like, you know, NaOH, 1 molarity, then you're going to add another 1 ml of 6 molarity hydrochloric acid and see what is going to happen. Observe. Okay? So maybe this is going, because it is an acid, maybe it is going to react with the base, and then we want to return it back into the acidic part, right? Now, remember, if I want to show you what is going to happen, C double bond OH. This is acid, right? Carboxylic acid. When you reacted with NaOH, right? What is going to happen? Acids and base. Going to be neutralized, right? So we're going to have C double bond O minus Na plus we're going to make the water. So those guys going to make the water. So that's when you're going to add 1 molarity of this guy. What is going to happen to this when you add HCl and it is 6 molarity? This is very, very strong. Try to be very careful today because we have strong acid and strong base. And those are very corrosive, okay? Especially 6 molarity hydrochloric acid is very, very strong. So what do you think is going to happen? It is going to return back to the benzoic acid. So if you see precipitation, that reaction went through, right? So we're going to end up having, again, acids and base, and this is going to go back to OH. So this is NCl minus in the actual solution. So that's what you are going to observe today, all right, for the acids and base. We do the same thing with the lysine, but because of the NH3, right, we don't know with the water, with the sodium hydroxide, it is also going to abstract 1, right? So the same in the same manner, when I have NH2, and then I have CH, and I have C double bond O minus, and here is NH3. In the presence of base, which is NaOH, 1 molarity, we're going to end up having that compound neutral. HC double bond O minus, and then here it is going to be NH2, and here is the Na plus. That's how it's going to look like. Now, when you're going to add HCl again, HCl, which is 6 molarity, what's going to happen? Okay? So this is RG. This is exactly what we are going to do. I tried to explain it to you. This is, again, we're going to have 30 milligrams for each one of those chemicals. And then we are going to experience that here it is exactly the same. You have 1 molarity HCl, and then you're going to add the base to it. We don't have 6 molarity sodium hydroxide, so try to, go over the same thing with that one. First, 1 molarity sodium hydroxide with L-lysine, and then after that you add the hydrochloric acid to it as well, okay? So basically this is what we are going to have. I tried to give you as many information as possible. Hopefully you were able to go back to your, book. And in the book, it is really very nicely, they actually put everything into tables. Did you see that? Everything is in part, if you look at it, it's page number 12, 13, 14, and it goes all the way to 15, and we have critical thinking that you have to answer as well, right? For today's experiment. All right? So everybody, you need your test tube rack. You have the test tube here. All the chemicals is under the hood. You need your goggles. You need, if you want to use like gloves, the gloves is here. Although I don't, with HCl, usually I would not prefer to have like very strong acids or base, because if it is going, those kind of the latex, it's not the proper gloves that we need for the strong acids and the strong base. So try to be very careful. I would rather have it without those kind of the gloves. But if anything happens, or if there is any spill, immediately wash it with water thoroughly, and hopefully we're not going to have this. But just be careful. You need your goggles, and wear your your lab coat, and you can always start. Thank you.